Jeff Foudy is our first speaker today, and he's the founder of Deep Learning for Earth Observation, a company that's dedicated to providing services to develop and qualify artificial intelligence on satellite imagery. Jeff focuses on creating custom object detectors for objects such as commercial aircraft, ships, vehicles, oil storage tanks. So really exciting side. I had a wonderful stint at Maxar where we tried to solve a lot of these problems, and it's incredibly challenging to get a really good, robust object detection algorithm that works across a wide variety of geographies and biomes. So really excited to hear what Jeff has to share with us on his story today. So without further ado, Jeff, you want to jump on stage and get rolling for us?
Yep. Yeah, thank you for introducing me, and good afternoon, everyone. Yeah, definitely. One of the question, can you see my screen? Can everyone see my screen? Yeah, one of the things that I've over the 10 last year, I've been working in AI, applying satellite imagery, and one of the main questions that I got was actually, how can I test the model? How can I display this this prediction on satellite imagery easily? It was always a very complex endeavor to do something like that. So when I first encountered Fused a few months ago, and Sina and Plinio, I immediately thought that would be what I could use Fused to do, to create, nice, very interactive demo that can actually show the power of AI on satellite imagery. So I just want to go through and show you what I've done, and go to a little bit of code and see how it works. So here's the Fused workbench. And so the first thing that I have to do...
Sorry, Jeff, could you share screen again so we can put it on screen?
Again, yep.
Something happened. Thank you.
Okay, present share screen, yep. Okay, yep, that's... Okay, so I had to, I started again. Can you, everyone see Fused?
We're good.
And can you, yep, and the workbench, okay. So the first thing that I have to do is display satellite images. Okay, so I think that's been done many times, but I just want to show it how it's done in the workbench, because I think that's super easy. The only thing that I have to do is I get my image. In this case, it's a Pleiad image at 50 centimeter resolution. It's a huge GeoTIFF cog file. I just need to put it somewhere on Amazon or Google Cloud, and I just need to reference where it is. This is where it is. The TIFF image is here. And then I just need to write the little piece of code that will extract a little tile from this big image and display a little tile. So when I show that, that's my full image. That's actually an airplane graveyard somewhere in Arizona near Tucson. And okay, so every time I zoom, and you see the little change pending here, every time all the tiles are recomputed in parallel. I'm using GDAL. I'm just extracting the little image, little tile, and then projecting into the web Mercator prediction. And this is all done on the fly. And I can see how easy, how the streaming is super easy. I can move one side to the other. So like 10 lines of code, a cog somewhere on Amazon, and boom, I got the image online. The next thing I will do using what Sean mentioned as a UDF, the user-defined function, is to define a function to do the AI, to do the machine learning on the imagery. So again, what I will do, I will take little tiles and I will apply my model. So that's what I'm doing. That's my work to create these models and generate like vector files. So my UDF this time will not generate a raster file. It will generate a vector file. And I just need to do, this is the coding here. And as you see here, I got the prediction for all the plane that is computed. Okay, so I display them as little rectangles. And in that case here, what I do, I don't do the prediction for every single tile, because my image is a 50 centimeter imagery and I want to use the full resolution. So I will not apply it on other zooms than the full resolution. So what I do actually is when I hit zoom 16, I start to compute the prediction on like a bigger tile at the resolution that I want to apply the model, because each model is usually linked to a specific resolution. I generate all these little square, and then I project the square. And if I zoom, I still projecting the square. And that will lead to a little issue that we can see here, for example, is that I got sometimes double detection, and that's because I got tiles. And this is something that you cannot avoid, because any model will be trained at a specific resolution, a specific size. It could be 256, 1000, 2000, but there's always a limit. It cannot actually run on the whole image. It has to be on tile, a specific tile. So what we do in that case, we will use a margin. So I will make a bigger tile, make the prediction on a bigger tile, and then have some overlap so I can remove this double detection. And I do that here. So at the same time here, we'll see how I can modify the code and then just save the code immediately. All the vector will be recomputed, and then I've solved my issue because I got a margin now that that enables to do not have duplicate detections. Okay, so we got the workbench. I can do the code for one tile, and I can apply it immediately. I can do anything I want here. I can do stupid thing, good thing, whatever. I immediately see the result, and it's a very Pythonic way of working that I can see the result immediately. So now I got my demo. So what I can do here is I can go in this part here where I've got the HTTPS link to these layers, the raster layer and the vector layer. And I can easily create a web map that will enable me to go on my website, and I've got everything that I do here. Here on the aircraft, I'll be able to see the Fuse demo. And that will bring me to a demo that I created, but that is just using the vector that we saw. Yeah. It's not displaying. Yeah, what is going on? Okay, then so I can, yeah, so I can see that should be displaying the demo here. It should be displaying the little rectangle here. It's not doing that. And as another example, okay, we got it here. Yeah, okay, so here's my demo, and directly I got all the little rectangles here. And I will show you quickly, just to finish, I will show you another version, which is this one. So just to finish, this one is another demo. Let me one sec. Fused demo.deeplearning.earth. Yep. This one. So this one is another played image on Hong Kong. And I'm using, in that case, I'm using a model that is actually not linked to a specific object, but I can actually type the object I'm looking for. So it's more like there's more interactivity. Like if I type car, it will send a request, and for every tile, it will look for cars. Okay. And I can move a little bit, and I can still see the cars everywhere. If I change my request and I'm looking for buildings, then it will immediately change and then look for buildings instead of looking for cars. So this level of interactivity, automatic computing directly on the map as I'm moving the images, I'm even changing the request and the keyword, is something that I was really super impressed by Fuse, and I'm going to use in my demonstration and potentially also in my workflow, because from this I can extract images and annotation, and I can train more models.
Yeah, definitely a lot of fond memories of using that same airport graveyard to do object detection.
Thank you for having me.
Yeah, cool. I think we have hopefully time for one quick question. Traditionally, you found like running AI models historically has involved a lot of designing and maintaining. It's pretty challenging multi-step workflows. Curious what you think some of the interesting capabilities that this rapid inference on live maps could enable for end users going forward.
Well, so definitely, I'm very focused on data-centric AI. So like we're not working too much on the model. We're working on getting a lot of imagery and with very good annotation. So one of the things I think of using this tool is, when you get a model, you can then go around and see how it performs in different environments and different size images. And if there's some places where it doesn't work that well, just click a button, store the image, store the annotation, quickly correct the annotation, remove whatever is good or keep what is good, and then add that to the model, train it again, and visualize it immediately. So I think it really participates in this data-centric system that we want to put in place, and that is very useful for people with a lot of imagery, because we want to work on the data and not so much on the model, and that's really enables very strong interaction with the data.
Yeah, it's a wonderful feedback loop, and amazing how quickly that can happen. Yeah,
I think Gabriel will also show. I mean, a little bit.
Oh, cool.
Yeah, later on. So yeah.
Awesome. Well, thank you so much. It was really wonderful.